So the last thing I want to talk about is a few cautions about graphs and graphics. So here's our learning objective for this section. So let's take a look. I have here two graphs that show women as a percentage of all college students. Both graphs show the same data, but they look very different. Why is that? Well, it's always important to check your y-axis scale. The difference is y-axis over here starts at 30%, which was the lowest percentage of the women in college, versus over here it starts at 0. So on the graph on the left, it looks like there was like a dramatic, right? This dramatic raise in the 70s of women enrolled in college. So on the second graph, we don't see that. It just seems like a steady increase. So that first graph persuades me to think that, wow, there was a huge increase of women enrolling in college in the 70s, when actually that was not the case. See how I could change your beliefs about the information based on adjusting my y-axis? So next we have supercomputer speed records, right? Both graphs show the same data, but they look very different. Okay, so let's look on the left, my data is in millions of calculations per second. And on the right, my data is in trillions of calculations per second. So million is a trillion times a million. A million times a million gives you a trillion, I think. So, right, both data look the same, have the same data, but they look very different because this scale is broken down smaller into millions, right? It shows that we've had this gradual increase in the ability of computers to do calculations. A million times a million. Next, on this graph here, because it's in trillions, it looks like computers were really, really crappy until oops, I didn't say that. We're really, really slow until 2014, 2015, right? This is misleading. Computers are really bad. No, they weren't. This first graph persuades me to think that there was a gradual increase, whereas the second graph makes me think there was this huge jump. Next, let's take a look at these two graphs. And what I want to know is college getting more or less expensive from looking at these two graphs? So again, we want to look at our titles. So this first one is changes in college costs. This second one is actual college costs. Okay, so if I look at changes in college costs, this is the percent change from the previous academic year, right? But if I didn't go to all the time to read about how if I didn't read my title, if I didn't read my y-axis, I would kind of think that it looks like the universities are trending down. Maybe I should use green. That the cost of universities is trending down, but what's trending down is the change in cost from the previous academic year. Whereas here on the right, this is the graph of actual college costs. You can see that it's kind of trending, that college is getting more expensive for both public and private four-year universities. So again, it's also important not just to look at the scale, but what the graph is actually presenting. This is the percent change. This is the actual change in dollars on the right. Last but not least, this is a pictograph. Pictographs are graphs that are embellished with additional artwork. Look how pretty it is. So this is saying the world population in billions of people. So first thing is that the difference in time between these bars is not the same, right? Between 1974 and 1987, that was 13 years, right? And then between 1987 and 1999, that was 12. And then we've got another 13, right? But here we have a difference of 123 years, right? That's not an even difference. Another thing, and this is something graphs should not do, is has 2024 happened yet? What about 2040? No, you cannot predict past the information you know. We can make predictions, but you should not put it in the graph. So be cautious of pictographs.